then we can get going. We'll start off where we finished last week, and let's just see how far we can get with this, so that we've covered a lot for you for your assignment. So let me see where we've stopped last time, and then we can go on from there. Okay, so basically last week we stopped off just before quadratic functions. So today we're continuing with that, and let's just see where we end. So I've got some notes up until topic 4, so let's see how far we can get tonight. Okay, so let's look at quadratic functions. It is always in the function of ax to the power of 2bx plus c. The only thing that might differ is maybe if there's negative signs in front of it or not. Okay, so, but for this one, they ask us to just look at the positive one for now. And then they give us a graph, and they ask us that we need to say, well, look at the graph, tell us what are some of the intercepts. So firstly, they ask us what are the intercepts on the x-axis. They basically want that point and that point. So what we will do is we will always, the y is always 0 on the x-axis. So if you look at it, y will be 0 at that point. So if we write it down in the coordinates, y's will be 0. The first one is always for x, so first x is -5, and the second x is -1. Okay, straightforward reading it off the coordinate or from the graph. So the same if we needed the next one to read the y cutoff. So that is where x is 0, and then your y would be 5. Okay, so +5, +5. What is the value of x at the vertex? Okay, let me Google that word. Let's see, what does vertex mean? Okay, so it seems like Okay, so let's see if you were right. Yes, cool. Thanks, Kyle. Can see Afrikaans is my first language, not English. So basically, what's the turning point? And if we read it off, the x is -3. I'm going to put in the y just that we have it. If I ask it at another place for us, when we have it, but your x, we would only have given it as -3, but I've just added the y as well. What is the minimum value of this function? Okay, and basically that will be the -4. So your turning point is where your minimum value is also going to be. So that is actually what we've done with that is -4. If the turning point was positive, or if the graph was negative, that turning point would have been a maximum turning point. Okay, so because your smallest number is basically -4, the rest of the y's are bigger, the minimum at the turning point is -4, else it goes up and becomes more. So in this instance, and I think that is another thing that, so with that smiley face, if it goes up, we have got a minimum. If it goes down, we've got the maximum. So that's one of the other ones that is also so important. Okay, and then the other thing that they ask us is, if this formula, in the formula, that and that is the value of a positive or negative. Okay, so positive or negative, we know it's turning up, so the A will be positive. If it was turning down, it would have been negative. Then is the value of a discriminant b to the power of 2 minus 4 ac greater than 0, less than 0, or equal to 0? Don't calculate the value. Look at the shape of a graph. Okay, that's quite an interesting one. That would have been interesting. I would have. So let's look at why they say it. I probably would have said greater than 0, but I might have been wrong. The discriminant beta will be bigger than 0 because two separate x-intercepts exist. Okay, so that is why. And it doesn't matter if that moved across. So basically, every time that you look at that, so that would have been positive. And what we would have seen here, so the big thing is just, is that B, and it's going through that point if you're going to calculate it out. So you're going to sit with A that is probably positive, C that is positive. So because that goes through those 2 points, it means that it will always be positive. So that is something I didn't even look at before. So that's quite interesting. So if you have, yes, is that somewhere in the study guide as well, Kyle? Or
I don't remember if it was in the study guide. I attended one of the module leaders' classes or one of her recordings, and she pointed out there that we have to learn what the discriminant is. So I don't remember where I saw it, but I saw an explanation about that somewhere.
okay, awesome. So I'm gonna do that, and I'm gonna copy it actually in here. I'll take all your names out of that copy. Just that. So this is something that must be in a study guide, because it's not something that I think we just would know. Some of the others, some of the others is things that you know, so like the vertex, like the minimum, maximum, but this is not something that we hear every day. So yeah, let's just, at least now also it is here so that you guys can see it whenever you get another question like this. And also then if it's negative, it doesn't have intercepts. So then if you get a different graph that looks different, then at least you also know the answer to that. Okay, so let's go to the next one. The answers is also, so again, I will share the answers as well. Then what we have in this one is the exponential functions. Then we'll get into log functions as well. But first, exponential functions. So again, when you guys are doing this, your exponential function, and you can see I've nearly written in something there, but it can be 2 to the power of x. So depending on what you now need to do with it, that is most likely how it will be. They can link this to some of the previous work and say you need to simplify it. So they can ask you maybe to do something like that where you need to simplify it. Again, very difficult. Okay, cool. Thanks for that. Where it is in the book, pages 163 to 166 in the book. So your exponential function is again one of those that, like, we're going to do now one where we're going to plot it, but again, they can't really ask you to plot something. So it's more, again, for you to be able, if I give you a graph, to read things off a graph. Okay, so what I'm now just going to do, so I'm going to draw a graph, and then we're going to add those in and see on a calculator what we get, and then we're going to plot it. So where x is -2, so let's make that -2. What is your y? So 2 to the power of -2 is equal to a quarter. So if I've got x here, y there, if I sit with -2, -2 will be 1/4. Okay, so my y, let's say that is 1/4, 2, 3. So let's say that is only 1. So that will be the point. So if I have -1, so 2 to the power of -1 is 1/2. So -1 and probably sitting there. Okay, so that was a quarter. That is a half. Okay, 2 to the power of 0 is 1. So 2 to the, anything to the power of 0 is always 1. So 2 to the power of 0 is 1. So where x, wait, we first needed, sorry. Where x is 0, I'm going to change that now. Where x is 0, Your answer is 1, so there it goes. When it's 1, your answer is 2. When it's 2, your answer is 4. When it's 3, your answer is 8. So you will see that that graph does something like that. Okay. So what it does, and we normally say it exponentially goes up. What do you also notice with the graph on this side? Okay, so what you will see is it will not go over that x-axis. So that will continue getting smaller and smaller and smaller, but it will run nearly adjacent to the x-axis, but it will not go over it. So it will just get smaller and smaller and try to converge with the x-axis, but it will not ever go over it, because you can see whatever 2 to the power, so 2 to the power of minus 100. So let me quickly get that for you. 2 to the power of minus 100, it is 0, with 11 or with 30 zeros, 788, but it's still positive. So it doesn't matter how small that x gets in the negative, it will never go over that axis. So that is nearly the most important thing that we need to know about the exponential function, and we see it in this piece of a work. These graphs always have a horizontal asymptote, because ab to the power of x can never equal 0. So if I want to ask you now a definition question like the one that was now asked about that e to the power, so that discriminant, this can be a very nice summary of something that they can also ask you about exponential functions. So they can ask you about the exponential functions, about the constants, about does it have a horizontal asymptote or not. If it is like that, can your value ever be equal to 0 or smaller? So they can put that nearly into a kind of definition question. Then obviously with equations like this, they can ask you that as well. So if you needed to calculate that out, that just would have been something like 2 to the power of 3x. Okay, so if they're asking you, where they're looking at things like this, or they ask you to look at a graph and give some information. Okay, the same happens nearly with the log function. The only difference now is that you see it's turned upside down. So it nearly is the inverse of the exponential function. So you will y equals to the log of x. So depending on how you read it, but again, in both forms, bigger. So here it will always be bigger than x. So it will go again, run next to that line, but it will never be negative x. So very similar, you can see as well, if we look at exponential function. We look at the log function. The only thing now that is different is look at your traditional exponential function would have been, say, e to the power of x. So all that has happened is that your x is now the subject, and not your y anymore. So that's why instead of a function going up on this side, it's nearly a function that is turned the other way around. So that's the two differences between your exponential and your log function. Log function, again, what they can ask you, but that you can work out with your calculator, is if I said, work out what is log x 18. But that you can work out with your calculator. So if I ask you things like that, the same. If I ask you in an exponential function, 3 to the power of 4, something like that, you can work it out. So the same with the log functions. If I give you values in it, you can calculate it. You won't need to simplify a log function or anything like that. You will just need to replace numbers and calculate it. Or again, they can ask you some of the definition around the log function. I think with log and exponential, it's very important to know the definition sitting behind it. Okay, so that was topic 2 that we've done. So I know we started it last time. So we basically looked at, let me just cover what we've done. We looked at what the function, linear functions, quadratic function, and very, very quickly around exponential and log functions. Okay, so then topic 3 that we're going into is more on similar equations, so linear systems or equations. And here what we are going to look at is a few different types of equations. So the first one is a linear equation where we only look at one variable. So something like 4x plus 7 is equal to 10. That is a linear equation in one variable. Then we're going to look at systems of linear equations in two variables. So when we need to calculate, say, 4x plus 5 is equal to y, and you get another one that is 2x plus 1 is equal to 1. So that will then give, we will say that is a system of linear equations. Then the other two that we get is inequality. So then just again, your linear inequality, only difference is instead of being equal to, we will see that it will be something like a bigger as or smaller as. So now we can say 4x plus 7 bigger than 10 is a linear inequality. And then the same would apply to those two for systems of inequalities. What they also like to ask with system of inequalities is sometimes linear programming that we will look at. So it might be that when they give you two graphs, and they ask you or they give you a few graphs and ask you which one of these are um, telling us that it is a system of linear inequalities. So they can ask you that. Um, so they can ask you a few things when we get to linear systems. So they can ask you to calculate. So the first one we could have said, okay, but calculate x. The second one we could have said, but calculate x and y. In the third one, linear inequalities again calculate. But in the fourth one, they can ask you to say, but if you look at a graph, which of these are the system of linear inequality? So I'll show you some examples on that. Okay, let's go into what we have with linear equations. So again, just nearly the theory behind it. So when you look at a linear equation, you have a coefficient. So, and I think last week we learned about variables, or even the week before. So that could be something like 5x. So you've got your coefficient, which is for 5. You've got your variable that is for x. And your constant term could be something like +7. So they can ask us, well, where is your linear equation? Solve it. Okay, so we'll get to examples in the next one. And then what you can see is, so there's a simple one. It might be that they use brackets, so that you need to remember from previous work what's your order of operation that you need to take into account, or they can put it with a fraction that you nearly need to remember how we calculated fractions as well. And then from there you go into, after you've calculated or simplified the fraction, then you can go on to solve the equation. Okay, so we're going into, you can see, so what I've done is a combination. So we're first going to look at this one. And we're going to look at a nice fraction one, and just show you how to calculate it. Okay, so left-hand side, we've got nothing that we need to change to it. On the right-hand side, we've got brackets, and in front of the brackets, there's a minus. So the first thing would be that we multiply that into what is in the bracket. So first, we can rewrite some of it that doesn't change, but in the second one, we can change it. So minus times 2x will be minus 2x, and then minus times minus becomes positive. So minus times minus 3 becomes positive 3. Okay, so then easiest that I always want to do is take all the x's to one side, all the constants to the other side. But I also like it when my x's are positive. So to get rid of it, minus 2x on this side, I add 2x on both sides. So on your left-hand side, I will be adding then 4x, and this would have disappeared on this side. Then I need to take all the constants to the other side. So to get rid of a +3 here, I need to subtract by 3 on both sides. So that will disappear. But on this side, then I have 6 plus 3 minus 3. Okay, so then my answer will be 4x. equal to, so 3 minus 3 cancels out. So 4x is equal to 6. So 4 or x is equal to 6 over 4. And again, like I said last time, let your what is in the answer set determine how far you simplify, because that can also be equal to 3 over 2, because 2 goes into there 2 goes into there 3 times. So you can see we sit with 3 over 2, or if it is simplified to improper, this can also be your final answer as 1.5. But this nearly for me is, please look at your answers that you have and let your answer set guide you, because you don't want to go straight and simplify and make it 1.5, and then you don't see 1.5 as one of the answers because they wanted it as 3 over 2. So, but that is just at the end when you need to find the answer in the answer set. Okay, so then from there, we go to the next one. The next one is one of those that I need to get to the lowest common factor or denominator in this one, but nearly with that 42, it is very difficult. But let's see if we can simplify anything. That also doesn't look like that because 13 is a prime. So that is not, we can't say 13 divided 42 and get something smaller. So we will need to rather work with a 42. So how to get rid of a 42 is we need to multiply across all of them by 42. So our first step will be to multiply by 42. So if I multiply here by 42, so let's do it. I'll show you now how we will then simplify it. But let's do that first so that you can see what we're doing. And that is equal to 13 over 42. Okay, so now we simplify a bit first. So 6 going to 6 once, 6 going to 42 7 times. Instead of having a, just need to add that 42 there. Forgot about that nearly. So 42 times 13. Okay, so when I rewrite it, my fraction is gone that I needed to work with. Okay, so then do the same with 43 divided by 3. That is 14. And then in the bracket still the 1 minus 2x. And now on this side, if I divide the 42 by 43 or 42, I'm left with 13. So at least now my fraction is gone. And hopefully when I now multiply it out, we will get some better or quicker answer. So 7 times 4 is 28. 7 times 5 is 35. minus 14 times 1 is minus 14. Minus 14 times minus 2 is plus 28. And then equal to 13. So let's then first simplify. So there's a 28, there's a minus 14. 28 minus 14 is 14. On this side, minus 35 plus 28 minus 7x. I might have made a mistake somewhere as well, but so if let's not, unfortunately, let's take that to that side, so minus 7x. 13 minus 14 becomes minus 1. And then if we simplify, it is 1 divided by 7, which hopefully is the right answer, but you can also check that out. But this one is quite a long one. It would have been great if that was 14 over 42 and you can simplify it at the beginning, then it wouldn't have been this long way of simplifying with a fraction. So normally you will, and when I looked at the previous, so year where it's 6, what would have happened is you might have added very simpler with the 2 and the 3 and the 6. So it's more likely that it will normally be something like that instead of 13 over 42. But again, this is the way to work out if you need to solve the simple equation with one variable. Okay, let me first quickly stop here. Anything that you guys want to ask on it, or can we continue?
All good, my side.
Cool. Okay, so anybody wants to ask, you can ask. Stop me. Else, let's go on. So the next one that we're gonna look at, cool, is where we now have a system of linear equations. So what we have in this instance, and you can look at, I will share this in any case after the session, is ways that you can form linear equations. If there is some shortcuts on things that you need to look at. So if two lines are parallel, what can you get out of it? If two lines cross one another, what can we see? But what we need to do with a system of linear equations is basically every time you will need to solve for x and y, and mostly it is x and y. It might be that but they talk only two variables, so it can't be x, y, and z. It can only be two variables. Okay, so again, nearly what we will solve is, this is one example, and this is another example. And I nearly want to show you two ways that you can solve it. In the exam or in your assignments, and you would have now gone through this study guide, where they show you a few ways to solve it, you're going to pick a right answer again. So things have changed a bit where they're not marking it as in seeing what you have written and those kind of things. So choose the method that is easiest for you. So that's why I want to show you two methods, and then you can decide how you want to use it. Okay, so I'm going to do the first method. I'm going to work with this. So on the right-hand side, going to work with these two. Okay, so that is your first formula. This is your second formula. So I check it out and I see, here's something very nice. 2y minus 2y. So I can say, well, let's add formula 1 and formula 2 together. So I'm going to add those two together. So what I get is 4x minus 2y minus 2y is 0. So that disappears. And then minus 5 plus minus 3 is minus 8. Okay, so then this one I can then easily say, well, let's divide on both sides by 4. So my x is minus 2. And then all that I do is I substitute that into any one of the formulas. Doesn't matter which one, you will get the same answer. So I then said, okay, let's substitute it in the first one. So minus 2 plus 2y is equal to minus 5. So 2y is equal to, and that goes over to there, is minus 3. So y is equal to minus 3 over 2. And now again, it can be 3 over 2, or it can be minus 1½ Okay, so this is again two ways that it can be in the final answer. So that was one way of doing it. We then got rid of the y. With the first step, calculate the x, substitute the x backs in, and get your answer. Another way is to say, ooh, okay, I see 5x. Let's multiply this by 5. So I multiply the second one all by 5. So I get, my first one is 5x plus 2y is equal to 13. Then I multiply the second one by 5x, or by 5, sorry. So 5 times that is 10y. And 5 times 9 is 45. And then I say, well, okay, so that is formula 1, formula 2. Let's subtract the first one from the second one. So 5 minus 5 is 0. 10 minus 2 is plus 8y. 45 minus 13 is 32. Then I can say, well, let's solve for y. Divide by 8 on both sides, so y is equal to 4. I put y back into, let's say, that function. So x plus 2 times 4 is equal to 9. So x plus 8 equal to 9. And x is then equal to 1. And we can test it up in this one. If x is 1, that's 5. If y is 2, that's 8. That would have given you a 13. So that's one way of doing that. There was another way of doing that, but you can also see what I could have done here is also said, if that was my first formula, and that was my second formula. Let's make some space here. I could have said, okay, but let's go for option 1 minus 2. So 1 minus 2, 5x minus x would have been 4x. 2y minus 2y would have been 0. 13 minus 9 would have been 4. So again, x will be equal to 1. Exactly the same as what I got with the other one. And if I put that back, say, into the first one, I get 5 times 1 is equal to, sorry, plus 2y is equal to 13. I sit with 2y. If a plus 5 goes over to that side, 13 minus 5 is 8. And you see again, y is equal to 4. So in the end, you guys only will need to give the answer. So doesn't matter which option you use as long as you get to the correct answer. So please, when you need to solve for system of equations, look at what is the easiest way to solve it. But also what I showed my students, I think it was in DSC, another way that you can look at it, and I'm all for technology, is there are online tools like you have online calculators or some of the calculators that are very clever that you can buy. So there is also online tools. I'll put this link into the, it seems like my internet is just as fast as my Unisa today. So let me just see if this will open up. Okay, so wait, it wasn't, I think it was that one. It was the next one. Okay, so you can, wait, where is the, yeah, it was this one. See, so you can, no man, I had, just get the right, web page that I can put in for you guys. But you could, okay, I need to find the one. Can't help tell you there is a nice website and then I don't show it to you, so okay, so let's, so here it is. Okay, so what you guys can see is you can put in your equation. You can put your equation if there's more than, so let's quickly check. I'm gonna quickly take it to the other side, to my second screen again, just so that I can type in, and then I'll bring it back. So 5x plus 2y is equal to 13. Second equation was x plus 2y is equal to 9. So let's bring it here and let's compute and see if it works. Let's put in that. Okay, so there it was, x equal to 1, y equal to 4. Okay, just put in zeros in the other one. So what I will do is I will share this with you guys that you can also use it, because it is a nice tool to check your answers as well. So please use it. You can also use your calculators, you can use Excel, you can use any of those other methods as well. Okay, so that is on solving for a system of equations. Then the next one that we're looking at is just the inequality. So and the 5 inequalities is smaller than or less than, greater than or bigger than, then it is less than or equal, because there's the equal sign is included, greater than or equal to, so that one, and then the not equal sign is to equal. So it is just not equal, bigger or smaller, smaller, bigger or equal, smaller or equal, smaller or bigger. Okay, so that is your 5 inequalities that we normally work with. So then what you will do is you will, when you need to calculate the inequality, you follow the same principle as you would have had to with calculating the equality. So exactly the same. You got the 6x plus 4, other side 4x minus 3. So what I normally do again, let's bring all those x's to one side. So 6x minus 4x on this side, smaller than, and on this side we've got then minus 3 minus 7. Okay, so 6x minus 4x is 2x, and that is smaller than minus 10. So x is smaller than minus 5, because 10 divided by 2 is 5. And that is how you work it out. If it was the equal sign, you would have done exactly the same. So nothing changes just because we now have an inequality. The smaller than only change if there was a minus in front of x. Okay, so then it changes. So let me quickly, now that let's write one down. So 2x plus 7 smaller than 5x plus 9. Okay, so again, what we do, take the 5 to that side, so 2x minus 5x, and Carl, that's why I like normally to take it to the side that stays positive, but let me show you the two ways as well. So we're now taking it to that side. On this side, it's 9 minus 7. So we've got minus 3x, which is smaller than 2. So then it becomes, because we're going to divide by minus 3, then it becomes x. We're going to swap that around. And so when there's in front of the x a negative, and we want to change the x from a negative to a positive, we need to swap it around. So that is where we change the smaller to a bigger than. Okay, so it is at that stage. What I normally like is to, so yeah, so it's only with the x, and I think that's the important thing. What I like to do normally, and let's just see, maybe if I write it down in this space, there might be enough space for that one, is where we took that 5 over to that side. What I normally want to do is want to have all my positive x's on one side, but I don't need to work with a negative x. So I would have done, with this example that I've written down, I would have done the opposite. So I would have said, okay, let's take the 2 to that side. So then it is 5x minus 2 on this side. And on that side, I get 7 minus 9. And when you get, oh, sorry, 2x. So on this side, we've got 3x. On that side, we've got minus 2. Now we're going to divide by 3, so it stays positive. So it stays that sign. So then I don't need to change the sign, but read that x is bigger than 2 over 3. X is bigger than, or sorry, minus 2 over 3. X is bigger than minus 2 over 3. So it didn't matter. I know they like to write it that way because mathematically it looks better and those kind of things, but we actually got the same answer. And then without nearly needing to remember nearly to change the sign, because yes, if you want to change it from a negative x to a positive x, you need to change the sign. But if you did it on the first one, you just read it from the other way around, you get the same. So again, please use what you nearly feel is the easiest. And yes, Carl, so that you don't nearly make that mistake every time, because one is so used to, okay, if you change it, you need to swap the sign, but it's only when you look if there's a variable with that. Okay, so now we have inequality that we also work with brackets. So nearly the first thing again to remember is your order of operations. So the first thing, make sure that your order of operation is correct. So 2 times 7 is 14x. 2 times minus 3 is minus 6. Smaller or equal to 12x plus 6. Okay, so that was nearly the the one that is the most important is to multiply it out. Then again, I love to have all my positive x's on the one side. So 14x minus 12x is on the one side, so that will always be positive. And when it is on the other side, going to take a minus 6 over, so it becomes 6 plus 6. So 14 minus 12 is 2x, small or equal to 12x, and then get your x that is small or equal to 6. Okay. So again, if you've done it the other way around, you probably would have gotten in the end that, because then you probably would have changed some sign. So let me not not do that. You can test it out by changing it a bit and then see what your answer is, but it should be the same. Okay, so that is a set of inequality with one variable. Then we get these ones with two variables, and that is where I've now included two things for you. One that we solve as we did with the variables when it was linear functions and there was equals, and then something like this where we're using linear inequalities, and you need to say, but which graph is this looking at? Or this is the graph, which of the four of these answers is actually this one. Okay, so let's first look a bit. So with the graphing of inequalities, what normally happens is the area that we color in is where we say, okay, but y is bigger than. So y is bigger than that area. In this instance, it is going to the other side, so y is smaller. Okay, so that is nearly how we look at the inequalities when it is on a graph. Okay, so let's quickly look at a normal where they would ask you solve x and y. So for this one again, I looked at it and I'm like, okay, easiest will be to say 1 plus 2. So linear equation 1 plus 2. So that gives me 6x minus y plus y cancels out. Now that this is interesting, and remember what you are doing is solving for x and y. Okay, you're not going to work out the area now. You're just solving for x and y. Okay, so this you can actually ignore and just say equal to, because you're solving for x and y. Okay, minus 3 plus 5 is 2. So x then is 2 divided by 6, or 1 over 3. Okay, so just solving x and y, so then y would have been, and we would replace y, so y would be, so let's quickly see if we replace it. So then 4 times 3, okay, this is not a great example, because now it will be 4 over 3 plus y equal to 5. So that will go over to that side, so y then is equal equal to free and 2/3. Okay, so this was not a great example, but basically, if you needed to solve it, that is how it would look like. If you needed to graph it, then it's something different. But again, you won't need to graph it because they can't ask you to graph it. So they would rather ask you, here is a graph. Tell us there's one formula, there's another formula, there's two other lines. Tell us which ones are actually the correct options. Okay, so that is much more likely that they will ask. So if you look at this area that is the area that we accepted, it's bigger than, so y is bigger than 0. Else it might have been that here was a piece also that was colored in. So always y bigger than 0, but also it sits in that quadrant, so x is also bigger than 0. So those two are nearly always a given. So you will see those two are always a given. So if one of them said x smaller than 0, we could have eliminated it, but it didn't. So by just being in quadrant, what is that? Quadrant 1, I think. We have looked at those four and we couldn't exclude anything yet. Okay, so let's quickly check if by looking at any of the others, just by looking at the y cutoff, if we can eliminate any. So +3, +3, +3, +3. Oops, no. +2, +2, +2, +2. Also no. So no easy ways of calculating that or eliminating. So let me now, we need to say, go back to when did we calculate slopes? That was nearly the first semester, or sorry, not semester, the first topic nearly when we looked at that. So we will need to look at how do we calculate the slope of that line. So what we normally look at the slope is the change in y over the change in x. So that first point, the y is 3 and the x is 0. So that's going to be like that. Your second point here, we have your y is 0 and your x is 3. So if we had written the top one as a x and a y, and if we've written the bottom one as a x and a y, sorry, that should be 3. Let me just. Okay, so 3 over 3, or 3 minus 0 is 3. 0 minus 3 is -3. So 3 divided by minus 3 is minus 1. Okay, so then I know that line of x plus y equal 3. The slope is minus 1, so my x is going to be negative 1. So there's a negative 1. There's a negative 1. Oh, come on. All of them are negative 1. So still haven't calculated or ruled it out. So let's then check. Okay, but it tells me it must be bigger. Okay, and it is still on 3 as well. So bigger and equal to. Okay, so not that one because it must be bigger and equal to. Okay, so we can look at that one, bigger or equal to. Okay, not smaller. We can look at that one, bigger or equal to. Okay, so not that one, not that one, because the area that's colored in is to the top, so it needs to be bigger or equal to. Okay, so at least we've eliminated 2 options, but we're still left with 2. Okay, one says bigger or equal to minus half, other one smaller than minus half. Okay, so again, if we're going to use, that is going to be the other line. Again, it is bigger than, so again, it will be bigger or equal to, so it will be that one, the bigger or equal to, and not the smaller. So that would be, again, a way to eliminate. If this was, instead of sitting there, it was, yeah, in that space where it was there. If that was my, then I still would have had the top one that's bigger. I don't know. I would have had, yes, well, top one that goes through there would have still been y is bigger or equal to minus x plus 3. But that line, it never crosses that line. So it never crosses that line. So my second one would have then been smaller or equal to the minus half plus 2. Okay, so if it was that one, the one in red, the top one would still have been the same, because if I go here, it's still above it, but the second one is below that line that goes through there, so it would have been smaller or equal to. So then there wasn't an example. That one would have been the closest, but then that is how it would have been if the red one was that component. So yeah, this is also a lot to do with linear equations. So if you want to look at, again, so that same, this same slide, let me quickly just look for linear inequalities into variables, and you have also calculate a graph. Quickly get you an example for that as well. So here you can see, and I will copy this in for you guys as well in the chat. So you can nearly use any of those functions to write a formula for you, but if it was, let's quickly get that one that we now looked at. So I'm just going to say y is big or equal to -3 or what, minus x plus 3. And then the second function was y is bigger or equal to minus 0.5 x plus 2. So let's just see. So there I've written it in. I hope my functions and everything is correct. Ugh, that doesn't look like the same thing. That we can all see it. Let me just see if oh, okay, so I also need to include the x bigger or equal to 0, y bigger or equal to 0. Let's quickly check when I include that and I graph it. Okay, so there you will see the area that we are looking at now is the same. Okay, so that is for one. So you can now look at this and take away some of the graphs. Then you will see, okay, it's only this area that it will be, and then only the next, and then only the next, and then only the next. So play a bit with it so that if you want to see how you add graphs and things to it and it changes. So that is always, it just makes it a bit more, how do you visual so that one can see how the things change. It's, for me, it's always very difficult when it's the one color, and sometimes when you see some of the things, it's printed badly as well. So it's nice when you use for online tools and then it overlays it and you can actually see what it means if you want to look at a graph like that. Okay, this is something that you will probably get. So what they can also do nearly is the inverse to ask, and they give you a few inequalities and say, well, here is 4 inequalities, here is 4 graphs, which one is the right one? So they could just do it for opposite to say, here is the inequalities, nearly draw it for me, but then which one of the four options is the right one? Okay, so it might be that they swap it around like that as well. Okay, then let me first stop here before we go into, we are doing a lot tonight, before we go into some of your maths in finance type of questions. So any questions up until now?
All good on my end.
Cool. Okay, so let's do the next section. Okay, so next session. So we're jumping now from normal maths to some other maths where we look at finances. We're going to look at simple interest rates, simple discount rates, compound interest, then time value of money, some annuities, amortization as well. I'm also going to show you when we work through some of this, how to use Excel. Then also, if you have any financial calculators, just in the chat, nearly tell me which financial calculator you have. If you don't have, it's also fine. I am going to show you some of these things, how to calculate it in Excel, that you don't always need to now go and buy a financial calculator. It is really not always the value worth. Okay. Okay, so the Casio is quite nice. It really covers all the functions. Let me quickly check. Check if it covers all the. Okay, if it doesn't, it's supposed to cover all the other functions like future values and things like that. Okay, LZ, I also got the. Yeah, Carl, I think that is probably yours is more of a scientific one. I also got the HP, so I will say I will do it on HP. But again, Carl, don't go and buy the HP. Check a bit on apps on your cell phone and on online. There will also be financial calculators, and then obviously I will show in Excel. Okay, so let's look the first one, simple interest. And simple interest, I think what you the important thing about the simple interest is that they can nearly ask you two questions around simple interest. So the one question is around calculate the interest. So not anything else. You calculating the interest, so you can use that simple interest formula, which is straightforward. If you want to calculate the interest, you basically just say the amount, which is 10,000, times the interest rate, which is 12.5, times my period. And here it's 90 days, so I need to say times 90 divided by 365. And that will give me my interest. Okay, so that is straightforward. You don't need to use any specific calculator for that. That you can just work out by 10,000 times 12.5% times 90 divided by 365. And that answer would be something like 308 Rand and 22 cents. Okay, so that is, if you needed to work out the interest, they could have asked you to say, but okay, so now you've worked out the interest. What is your total amount that you now have or what you need to pay back. So then it's just the original amount plus the interest. That will then be your nearly what we call your future value or your total amount of repayment. Okay, so that was nearly, if you need to work out interest, straightforward, use the formula, the, the principal amount times the interest rate times your time period. Also, what is important is when we look at time periods of days, we use 365 to divide. That is, they don't need to tell us that. But if I tell you a time date or something, it might be that they say 360 days or something, but then they need to tell you that. Else we assume that it is 365. So I think that is just important. It is, the assumption then is that it is 365. Okay, so that is when we just look at simple interest. They can also ask you in that question set nearly how much simple interest is payable on a loan of 20,000 borrowed for a period of 1 year at a simple interest rate of 10 per year. Okay, so again, what we could have done is to say, well, that is the simple interest, but let's look at another formula that we can use. So it is interest, or R times N. So our final amount, S, would have been the principal amount, 20,000, times 1 plus, they tell us for 1 year, so that, and they tell us it's 10%. 10% times 1 is going to stay like that. So 20,000 times 1.1, and that is supposed to be 22,000. Okay, so then, okay, so sorry, they just ask for simple interest. So again, we would have used that one for the simple interest, which would have been I times P times R, which would have been 2,000. I thought they wanted the final answer. Okay, but here is an extra formula for you that you can use if you wanted to do it this way without working out the interest component first and then to add it. You can use this formula for that. Yes, perfect. You could have done that as well. So you could have said 22,000 minus 20 and get your 2,000 spot on. Okay, cool. So simple interest is basically just, it's not interest on interest, that is compound interest. Simple interest, just a basic calculation sum. Also, your financial calculators is built to do compound interest. It's not built to do simple interest. So unfortunately, with simple interest, you still need to nearly follow the formula to work it out. Okay, the second part nearly of the simple interest and is the simple discount rate. So here, basically what will happen is, which again will be worked out on the value that they tell you you are getting on the discount on times the discount rate times the time period. So very similar to the interest and N and the payment or the starting, you're doing here the same. Okay, so determine the simple discount on a loan of 3,000 due in 8 months. So we've got due in 8 months. That is quite at a discount rate of 11% over 90 days. Okay, so wait. I think I this should not be here. Okay, so that other part was confused with this one. 8 months, because we've got the other time period as well. Otherwise, I'm giving you guys 2 time periods. So it was the determine a simple discount on a loan of 3,000 due in 8 months' time at 10% or 11% per annum. Okay, so that would be the discount that we will calculate. So 3,000 times 8 divided by 12 times the 0.1 is 220 discount you are getting. Okay, so basically by saying we will give you a discount of 220. So you get a discount on that. Again, we could have now asked, but so what will that be? Over 3,000, it's 3,000 minus 220, which is then a bit smaller. So always remember with this now, when it is discount, your value will be smaller. When it is interest, your value will be bigger. We get a set of answers. One might eliminate a bit of that answer set. Okay, now we're getting to compound interest. So again, going to use the formula a lot, but also going to show you how to use Excel. So calculate the accumulated sum of 500 invested for 10 years. So we could have, where is my, so we could have added it. So we could have said, okay, but what is the amount that we need to pay or get at the end? So it is 500 invested for that 10 years at an interest of 7.5%. Okay, so we could have worked that out. That would be 7.5% plus 1. I'm just want to show you. Go to the power of 10. So I get something like that is equal to 150.52 if we round it off. Okay, so that is, if I say that to the power of 10 times 500, that is how we will get to the S. Okay, so let me quickly show you in Excel, because this now is a simpler question. Let's do something like this in Excel. So we've got your S was 500. We had your interest rate as, what was it, 7.5%, and N was 10. 7.5% and N was 10. Okay, so we wanted to work out what your future value is going to be. We could have gone, okay, let's go to, this is weird. Why is my normally set up? Okay. So what is your interest rate? You can put it there. How many times per year? We're not doing any payments in between, so that is 0. We've got a regional of 500, and we are paying it at the end of the period. There you have the answer of 1,030 Rand and 52 cents. Okay, exactly the same. So again, you can decide which one you want to use. I love Excel because that is nearly part of what we are doing every day. But again, you decide. There is, and I'll share this as well on WhatsApp tonight. So don't worry. I will also I'll save it afterwards. But I'll share that tonight with you as well, that you can see how to use Excel. And now it is there for you, so you can just change those numbers as you feel for whichever example you need to do. Okay, so that is compound interest. Again, doesn't matter which formula you use, you will get exactly the same. You can use and LZ, you can, if you used your HB, you could have, okay, I normally just clear all my, but you could have said, okay, 500, and let's just remember negative 500 is my present value. 7.5 is my interest. Then I do it for 10 years, so 10N. And if you then press your future, let me just change my, that is not 12 times a year, it needs to be 1 time a year. Then if you press your future value, it is also 1,052. You got that on your financial calculator as well. So on the financial calc, yes, please ask. Oh, okay, cool. Okay, perfect. So again, can do it on the financial calculator as well. And you can test it on Excel. What I've included for you guys is just sometimes when we need to convert things, so if I talk about monthly or quarterly or semi-annually, half-yearly, I always get confused with that one. And annual and yearly, just what you need to do with the interest rate period, and then what you need to do with the time period. So if this was monthly, you would have needed to divide by 12, but that you would have multiplied by 12 again. So that you will now be able to see in here that your number of time periods you would have multiplied by 12, but your interest rate you would have divided by 12. So just this is a nice graph just to have with you, especially when they ask those weird time period ones. Okay, so what you will also get is a question around time value of money, but it is more so what they want to test with something like this is that you can nearly draw a timeline. And again, they will not ask you to draw a timeline, but to help you to get to the answer, it helps you to draw a timeline. So imagine that was a straight line. So let's look at what they're saying. So MJ must pay the bank 2,000, which is due in a year's time. So in a year's time, must pay the bank 2,000. Okay. She lessens the burden and pays 600 after 3 months. And another 800 3 months later. 12% interest rate compounded quarterly. How much must she pay at the end of a year to settle her outstanding debt? Okay, so basically, interest rate is compounded quarterly. So what is important is that we will divide by 4. Okay, so the first thing is there's 600 Rand that she paid off after 3 months. Okay, so let's work that out. We could have now done it on Excel, but I want to show this nearly in that we can see the timeline as well. So 0.12 divided by 4 gives you 0.01. If we add 1 to that, it's 1.03. So 1.03 to the power of 3 gives us 1.09. So 600 times a rounded off 1.09 gives us 655.94. So basically, what she now did was for that first 3 months, he paid off 600, but that 600 would have been 655.94 because that was the interest that was compounded quarterly. Okay, so that was the amount that she should have paid off. When you look at the second one, do exactly the same. We're just now sitting with 6 months. So 800 1 plus 0,12 divided by 4 because it's quarterly, but now it is 6 months. So if we work out that answer, 0.12 divided by 4 plus 1. So again, it becomes 1,03 to the power of 6, which is 1,19 times 800. So that gives us 955.24. And then you can see in my calculation that I added here. So, ooh, why did I say times 900 and not?
Your period is to the power 2 instead of to the power 6.
Okay, let's see quickly. Why did I do that?
Maybe you're thinking that it's 2 quarters instead of 6 months.
Yes. Thank you very much.
My pleasure.
And that is how quickly one can make a mistake, eh? By 6 months and that is why I thought about it as 6 months and not as 2 quarters. So 6 months is also 2 quarters, makes a massive difference in the answer. Sure, okay. And that is how they trick you in the exam as well. So let's be honest, that is how they're gonna trick you or try to trick you in the exam. So we made the mistake now, so you will not get tricked again. Yes.
But then in the first calculation, we raised it to the power 3. Does that not mean the equivalence of 3 quarters?
Yeah, so I'm gonna quickly show you what was supposed to. I'm gonna explain that now again. So let's just quickly get to 844. What was it? 848. Okay, so let me just take this away and then quickly explain again. Okay, so basically she needs to pay the 2,000 at the end of the year. She basically decides, okay, after 3 months, she's going to pay 600 Rand. Okay. So what we actually calculated here was for 600 plus 9 months of interest. Because she didn't need to pay that extra 9 months of interest. Okay, so she paid 600 there, and by paying 600 there, she didn't need to pay the extra 55 Rand 94 because she's paying off earlier. The same with the 800, because she's paying 800 here, we actually give that 6 months to her, that she's not paying extra 6 months because now she's catering for that earlier. So by then saying she would have paid us 2,000, but with that interest nearly added to those 2 payments, she's paying us less. Okay, so then she's paying us 2,000 minus the 848, minus the 66 or 655. Else we would have just said, what is the 2000 minus 600 minus 800, which would have been 600. Now we're saying, well, because she paid it earlier, she is, in a sense, in this instance, getting a discount. And that discount that she's getting is that for that 9 months on the 600, she didn't need to pay extra. And that 6 months on the 800, she didn't need to pay extra. So she basically actually got about 100, just more than 100 rand discount on what she needed to pay. It could be something different that, yes, so that is, I think that is why I wanted to explain it again, Carl. That's why I said, let me quickly explain, because I originally also talked about it in reverse. The other thing that might happen, and that is more with investments, they can tell you guys, okay, Sam is putting away 600 rand now at 10% interest for 5 years. And they can say that is simple interest. Then they say, well, after that 5 years, he invested again for 10 years. But now that becomes a 10% compound interest rate. And then my case, how much will Sam have after 15 years? Okay, so what you then need to do is to work out with your simple interest rate formula, how much did we get up until 5 years from now? So that will be, let's say, on a simple interest, that will be your first future value that you will work out. So again, time value of money. And then we use that value as a new present value. Change the formula to not simple interest, but we change it to compound interest over 10 years, and then we get on this one a future value. So nearly, you put it away for a few years, simple interest rate. After that 5 years, you nearly see what your value is at that point, and then you nearly reinvest the money back, and then after that 10 years, again, you work out. So we could have done this and say, well, okay, let's do it quickly. I said it was 10% times 5 years. It was simple interest. So it was 0.1 times 5 plus 1 is 1.5 times 600. So after 5 years, that 600 has become 900 rand. And now we say, oh, okay, so now that is my new investment. So my new investment, I'm calculating it at 10% as the previous one, but it's compound interest. So then what is your future value? It is the 1.1 to the power of 10, which is 2.59 times 900, will give you something like 2334.37. Okay, but you can also just play around with this. But this is something that they are more likely going to ask you, because we're not going to have enough time tonight, but with annuities as well, that is exactly what you're doing. So here now we just changed it up a bit. So this is definitely, I think, something that you can play with a bit, and I'm gonna check if I've got some examples of this as well that I can share with you guys. But I think, yeah, this is, we've done a lot tonight. So I will definitely share everything with you. The recording, the presentation, and also the Excel spreadsheet, even though it now only has one calculation in it, but by the end of the term, that spreadsheet would be much longer. Okay, cool. Anything else, guys? Ooh, let me quickly get the attendance register. Thank you for that. Let's quickly see where was the previous link. Ha, I nearly forgot about that. So thanks. There's the attendance register that you can quickly click on and just fill in your details. While I'm stopping and recordings. Cool. So I will definitely share